The important section about matrix, inverse matrix method. Okay, and these are the formula that we're going to use. Okay, most of the time. This is the main, they're like similar. This is the main formula. Okay, you can use any, it's just the same. And this is how we test and prove if the formula is correct. And the identity that you see here, it's just to tell you that you have something like this. This is what we know about identity matrix. You have maybe something like this. That's what we say identity matrix. Okay, so now what we're going to do, we're going to start this topic, and later on you'll be able to understand and know how you can get to the inverse of a matrix. Now let's get right into it with one example that we can solve. So we got this question that we need to solve. Okay, and in one of the video I showed you how you can actually represent this. So I'll go just straight. So this is where you're gonna put x, y, z, and the unknown is gonna be that side. So let me just write it, continue where I left off. It's going to be something like this: -5, 2, 9, -3, -2, 9, equal 19, -4, 54. So we got this matrix, and we need to use one of this formula. Okay, I'll just copy the formula that we're going to use. Let's go with this one. It's just gonna be it will be just this exactly as what you see there. So this is what we're going to do. Okay, what you see here, the I you see here, this block. So I can even just write this formula as like this: co factor t transpose, and then we're going just to put here 19, -4, 54. Okay, so this is what we have. Now what we do is we need to find delta, the determinant. Okay, and we need to find the cofactor. Okay, let's start with the easiest one. We're going to find first the determinant. So we're going to start with we're going to find the determinant. That's what we're going to do on step 1. Now you may have a question: determinant of what we're going to, so it's gonna be this block. We're going to look for the determinant of this block that you see here. So it's gonna be, we need to find the determinant of 9, -5, 2, 9, -3, -2, 9. So in order to find the determinant of this block, there's also one way, one method we can use. I haven't showed you this method. Now I'm going to show you what is it. So what we do here, instead of using that previous method we use in one of the video, we're going to use this new method that you can see. It's actually fast and good. So we're going to copy this block, this two block here. So it's gonna be -8, 2, 9, -5, 2, 9. Okay, so we're going to copy those two blocks. Then we're going to apply these rules. When we're going to multiply, them like this. Okay, and don't forget there's a negative sign here. Negative the multiplication, the sum of multiplication of these terms that you see here. Okay, so which will give you, if we calculate, it's gonna be negative 8 times 2 times 9, okay, on the first blue, plus negative 5 times negative 2 times 9, plus negative 3 times 2 times 9. Okay, we close this, and then we say negative, don't forget about the negative sign, and then we're going to have to go up in the other direction, so it's gonna be 9 times 2 times negative 3 plus, okay, we're going to continue with the second one. It's gonna be 9 times negative 2 times negative 8, okay, plus 9 times 2 times negative 5. Okay, so this is what you're going to get. And then if you carry on the block, so it's gonna be negative 140. If you take this, you solve it out, 90 negative 54, negative 54 plus 144 negative 90. Okay, and the answer to this will give you 180 1080 equal to negative 188. This is the answer that we will get for the determinant of this matrix. Okay, and what we do next is we're going just to replace back with the formula, so you can see our formula is going to be something like this. Okay, cofactor transpose times negative 4 54. Okay, so now we have to solve out this cofactor. Okay, and in order to get the cofactor, there is what you should know is what we get. Before we get the cofactor, we need to find the my-row. Okay, and from there we find the cofactor, and then from there we're going to apply the transpose. Okay, so this is what we'll be doing now. So let's start with the my-row. So we're going to find the my-row of our block, because we're going to use this one. So we need to find the my-row of this. Okay, so now this is what's going to happen here. Okay, and if you remember, in order to, what we're going to do now is we're going to locate. So this is the first row, second row, this is the first from the first row. Okay, and we're going to solve according to the second row, then we're going to solve it according to the let's say the last column. If if I have to be so let's start with the first row, the first column, second and last. Let me correct this one. So this is how we're going to solve this my how phase. So what's going to happen here? So I'm going to remove 9 vertically and horizontally. So this is what is going to happen here. All right, so this is what we're going to apply the mirror phase. So we're going to keep what is going and in this form what we'll do is we're going to write the number that you see there. So what I'm gonna do here, just to save time, I'll copy this block here. Let me paste it. So what is going to happen here, I'm going just to delete what I don't need. Just to make this is what I'll get. Let me just position them the way that they should be. And this is the number that we calculate them from. So it's gonna be something like this. And the 3 is gonna be here. And this is what we're going to left off with. Now we're going to get this form here that you see here. So now I'm going just to correct some few things. This is what you see. So this is what we get. So actually this is the matrix that we're going to get. And then if you look, we kept the number, you see, we kept -8, that's what you see here, -5, that's what you see here, -3, what you see here, and what you see inside here, it's what you see, what we add there. And then we kept those two, so it's gonna see those two. We kept this block here, it's what you're gonna see here. So the same goes for what you see here, and so on, just to give you an idea of how we went from this to that. So now let's continue. We got this form. Now this is a matrix 2 by 2. We're going to work it out. So, and remember, it's gonna be this one times this one times that one, and remember there's also another negative sign there. So before you do anything, I'm going to remove what we see here. So for our next phase, we're going to remove this block. It was just to give you an idea of how we got to this form. So you can just remove this number. The reason that we kept them is just to give you an idea. So now what you're going to see from we move from this, we just remove those numbers in front of the matrix. It was just to show you where we got those values. As you can see, this block is what we get here. So we just remove the number that you see inside there, because it was just to give you an idea where we got those matrices. Now this is what we're going to remain with. And then if you work it out, this one is gonna give you 36. That's why you see we have 36. If you work it out, it's gonna give you 36, another 36. This one is gonna give you 0, because this one, and this one, they are identical. so you will get then a 0 there. If you work it out, you will get negative 86. And how do you work it out? If you take this one times this one, negative 8 times 9, and then negative, there's a negative here, negative 9 times negative 3, it will give you 45, negative 45, and the same goes for this one, and so on. So now this is what we call our my matrix. Okay, so this is what we get for our so we just got off my now we're going to see to switch to cofactor. Okay, in any case, how do you get a cofactor, and what does it mean to get a cofactor? So the formula that we're going to use is going to be negative 1 I plus j. Okay, so meaning it's like we're going to apply the row plus the column. So, and then we're going to change to apply it to the sign of inside this matrix. Okay, now what we're going to do is, let's just work it out. So we have a matrix 3 times 3. Okay, so now this is what we're going to use, but in any case, you still remember this formula. We're going to apply this formula. So it's going to be negative 1 row plus column. It's going to be 1. If you see, this is like an example of a 3 by 3 matrix. It's going to be 1 1, so which is going to be 1 plus 1, which will give you negative 1 to the power of 2, which will give you positive 1. Okay, and for this one, it's going to be 2 plus 1, which will give you negative 1 to the power of 3, negative 1. Negative 1, 3 plus 1, negative 1, power 4, negative positive 1. Okay, and then since I know already what's going to be that side, so this is what we'll get if you continue with those calculations. You get to this and so on. This is what you're gonna get if you continue. This is what you're gonna get. But anyway, since we're working with this 3 by 3 matrix, this is what we're gonna have. Now when we talk about cofactor, this is what we call cofactor. So we're going to apply the cofactor to that matrix that we had before. So you're going to apply the cofactor to this matrix that you see here. Okay, and what I'm gonna do is, let me just copy, and then I will change the sign later on. Okay, let me move this one up a bit. Okay, and this is the sign. So we're going to apply here. We're going to have positive, negative, positive, positive. We're going to times positive and negative, and here we're going to times negative, negative, positive, negative, positive. And the answer to this, what we'll get is, let me just move this one a bit up so that I can have some space at the bottom. So what we're going to get here, so it will be positive times positive. Since there's no sign, we assume that there was a positive here. Again, here we assume that there was another positive before that. Okay, and for 0 it doesn't matter. Positive times positive, 36. Negative times negative is gonna give you 18, positive 18. Positive times positive, 16. negative, since there was nothing, so we assume that we add positive, so to my positive times negative, which will give you negative 45, negative 22, negative 6, negative 27, and 0. So this is what we call our cofactor. And just to make sure, I'm gonna put it here. So this is where we're going to place our cofactor. Now there's no space. Okay, so now this is what we get as representation, and this is the cofactor when you replace it into the formula cofactor. Okay, so in our initial formula for the inverse of a matrix, for example, let's say this is what we have. Now we're going to look for the transpose. Okay, how we can apply the transpose. So this is one example, and what is it the transpose about? Okay, I'm going to draw another matrix here. Okay, and the transpose is it's just moving this block and place it in its here. So we're going to swap column into row and row into column. So that's what we call transpose. We're going to take the second one, so it's going to be negative 36, negative 45, negative 22. We're going to take another column, so it's going to be 0, negative 27, negative 6. So this is what we say transpose. So transpose is just moving, changing the row into column and column into row. So that's what we call transpose. Then and from there we're going just to go and continue with what we have, and this is a transpose. Then we're going to replace it into that formula. Okay, so this is what we get when we replace the transpose into that formula. Then the next thing to do is to work it out, so then we can get our answer. And I know the easiest way to go about this is let's just multiply this with everything inside. So it's going to give us so we'll end up with something like this. So I'm going to have 36 over negative 0.8, negative 36 over negative 108, 0 over. So this is what we're going to get if we multiply the denominator of that fraction with everything inside the, and since it's 0 over something, so all of this is gonna be just 0. Okay, so this is what we get. Okay, and let's do the rest. The next part, we're going to simplify each term. So we're going to simplify this one and that one and so on. So we'll get this. Okay, so now you take the simplification of numerator and denominator, then you're going to end up with this matrix, and then you're going to perform the multiplication of two matrices. That's what you see here. Okay, and if you have to multiply two matrices, what is going to happen is it will be, you will take this matrix times this one. So it's going to be row times column. Okay, for the first one, and then you work out the answer. Then it's going to be another row times column, and then another row times column. So then we're gonna end up with this. So when we times row times column, we're going to add them together, so then we're going to end up with 1. Okay, it's gonna be 19 times negative 1 over 3 plus 4 times negative 1 over 6 plus 54 times negative 4 over 24. So then you're gonna end up with negative 1. Okay, that you do the same for the rest, you will end up with this matrix, and then this is what you get for your final answer. And that's what we said on the formula before. It was x, y, z, what you get here. So you solve for x, y, z. So this is how you solve for, I'll put it here so then you can see. This is how you find the inverse of a matrix. Let's go back to what we did before. Move where we started. Okay. And I think this is where we started here. So this is where we started. So okay, second, third, like it was a long way to this block. Okay, there you have it.